Hello everyone, welcome to my channel Problematical. Today we'll discuss exercise 2.2 of Maths 10th Standard NCERT. Chapter 2 is Polynomials. The first question is, find the zeros of the following quadratic polynomials and verify the relationship between zeros and coefficients. So there are two parts to it. Let's write the given expression, which is x squared minus 2x minus 8. You have to find the zeros of the following quadratic polynomials. This is a quadratic polynomial. Quadratic polynomial means it has a maximum power of 2, x squared, which also means x will have two values. These values are called zeros, which you have to find in this question. You can do so by using middle term splitting method. I hope everyone knows this. This is already covered in 8th as well as 9th standard. I'm yet to do those videos. So when I do so, I'll put up a link in the description. X squared, this middle term minus 2x can be written as minus 4x plus 2x minus 8 following the rules of middle term splitting method. X minus 4 plus 2x minus 4. We've taken x common in the first two terms and 2 common in the last two terms. Again, from these two terms, this is first term and second term. You're taking x minus 4 common. What you're left with is x plus 2. Equating each of these expressions with 0. You get taking minus 4 on the right hand side and 2 on the right hand side respectively. X is equals to 4 and x is equals to minus 2. So 4 and minus 2 are the zeros of the given expression. Instead of expression, you can write quadratic polynomials. Quadratic polynomial. Now, the second part is to verify the relationship between zeros and coefficients. For this, you should know what is the relationship between zeros and coefficients. Zeros here are 4 and minus 2. The expression is x squared minus 2x minus 8. The general form of quadratic polynomial is ax squared plus bx plus c in expression form. This is given to you. If you equate the given part with the general form, x squared has a coefficient 1 in the given expression and this value is a in the general form. So by comparison, a is equals to 1. X over here, the second term is preceded by plus b. So plus b will be equal to, the coefficient of x over here is minus 2. And c is equals to minus 8, constant. Now, you should know the relationship between zeros and coefficients. For a quadratic polynomial, sum of zeros is equals to minus b upon a. And product of zeros is equals to c upon a. The given zeros are 4 and minus 2. So sum of zeros is equals to 4 plus minus 2, which is equals to 2. In this particular section formula, your right hand side minus b upon a is equals to minus of minus 2, b value is minus 2 upon 1, which is equals to 2. Product of zeros. Again, product of zeros is equals to 4 into minus 2, which is equals to minus 8. And c upon a is equals to minus 8 upon 1, which is equals to minus 8. From these equations, from 1 and 2, this equation is verified, and from 3 and 4, this equation is verified. So you'll write the whole statement that from equations 1 and 2, sum of zeros is equals to minus b upon a, and from 3 and 4, product of zeros is equals to c upon a. Hence, the relationship between zeros and the coefficients are verified. By default, these are the coefficients ABC. Next question. Second part of the first question. You have to do the same process for all the values. So, let's see. Find the zeros of the following quadratic polynomial and verify the relationship between zeros and coefficients for the second expression, 4s square minus 4s plus 1. This is the given polynomial or quadratic polynomial. By middle term splitting method, four s square minus 2s plus 1. Your given expression is equals to, taking s common, 2s common, get 2s minus 1. Here you can take minus 1 common and you're left with 2s minus 1. This is your first term, this is your second. Amongst the two terms, 2s minus 1 is common and you're left with 2s minus 1. So this is 2s minus 1 whole square. In this particular step itself, after this step, you can equate each of the expressions with 0. Obviously, the values are same, so you'll get repeated roots. Means repeated values of s. Minus 1 on the right hand side, s is equals to 1 by 2. Similarly, here also you'll get s is equals to 1 by 2 being the same expression. Getting the same value twice means the variable s has repeated roots. So, therefore 1 by 2 and 1 by 2 are the required zeros. Second part of this question would be to verify the relationship between zeros and coefficients. So let's calculate the coefficients first. For this, we'll have to equate the given polynomial with the general form. Which is ax square. Now, the variable used here is s. So we'll write the general form in s variable form. Bs plus 1. Equating these two, we get a is equals to 4. The coefficient of s is b and coefficient of s is minus 4. Therefore, b is equals to minus 4. Last term, capital C. C is equals to 1. So you've got 4, minus 4 and 1. 1 by 2 and 1 by 2. A is equals to 4, B is equals to minus 4 and C is equals to 1. Now we know that sum of zeros is equals to minus B upon A. So let's calculate sum of zeros. If you actually do it numerically, it's 1 by 2 plus 1 by 2, which is 1. Half plus half is 1. Second, minus B upon A, which is minus 4. B itself, the value of B is minus 4. So minus from the formula of minus 4 upon 4, which is equals to 4 upon 4, which is 1. Similarly, the second formula, product of zeros. Product of zeros is equals to 1 by 2 multiplied by 1 by 2, which is equals to 1 by 4. And product of zeros is equals to C upon A. So let's see what we get when you substitute C upon A. C's value is 1, A is 4, so it is 1 by 4. From this particular calculation, we come to a conclusion that sum of zeros is equals to minus B upon A, and product of zeros is equals to C upon A. Hence, verified. What is verified? The relationship between coefficients and zeros. The next expression is 6x squared minus 3 minus 7x. Six x squared minus 3 minus 7x. If you can observe, it is not in the standard sequence. The terms are not arranged in the standard sequence of decrementing order of the variables, of the power of the variables. So here, x squared term should come first, followed by the term x, followed by constant. So this is rearranging the given expression so that we have it in the decrementing order of their powers. Again, you can solve it by middle term splitting method. First value is 6, second is 3. So the multiplication should be minus 18 or minus 3 into 2 into 3. And you need a subtracted value of 7. So 9 minus 2 is 7. 6x squared minus 9x plus 2x minus 3. From the first two terms, you can take 3x common. You're left with 2x minus 3. And from the next two terms, you can take 1 common. 2x minus 3. This is 3x plus 1 into 2x minus 3. Equating each of these expressions with 0, you get and 2x minus 3 is equals to 0. Transferring 1 and minus 3 on the right hand sides, you have 3x is equals to minus 1 and 2x is equals to 3. X is equals to minus 1 by 3. X is equals to 3 by 2. These are the zeros of the given expression or given quadratic polynomial. This one is given, but we'll consider this as equation 1. Now, for the second part, general form of quadratic polynomial is equals to x square plus bx plus c. Equating this with equation 1, let's say this is true. Equating 1 and 2, we have a is equals to 6, b is equals to minus 7, and c is equals to minus 3. Now, sum of zeros. The zeros you have are minus 1 by 3 and plus 3 by 2. Minus 1 by 3 and plus 3 by 2. So you've just added these two zeros with their signs. You'll have to cross multiply to have minus 2 plus 9 upon 6, which is 7 upon 6. Minus b upon a. Now b here stands for the coefficient of x. So sometimes it can also be written as, instead of b, then write minus coefficient of x upon a. A is the coefficient of x squared, which is minus b holds the value minus 7 and a is 6. So minus of minus 7 upon 6, which is equals to 7 upon 6. So both values are 7 upon 6. Therefore, sum of zeros is equals to minus b upon a. Second part is product of zeros. Product of zeros, which is the multiplication of minus 1 by 3 with 3 by 2. These 3 will get cancelled and you'll be left with minus 1 by 2. C upon A is C's value, which is minus 3, upon the value of A, which is 6. Again, you'll be left with minus 1 by 2. Therefore, product of zeros is equals to C upon A. From these two conditions, your relationship between zeros and coefficients is verified. This is a short form for between. You should avoid it. So, between zeros and coefficients is verified. The verification itself means making sure that the two conditions, two equations, are satisfied for the given values of the expression. Next, the fourth value is 4u square plus 8u. So, 4u square plus 8u. If you can observe, the third term, which is the constant term, is missing. So you need not require the middle term splitting method to get to the values of u. You can directly take common. The common values are from the two terms 4u. U plus 2. By equating them with 0. 4u is equals to 0 and u plus 2 is equals to 0. You get u is equals to 0 and u is equals to minus 2. These are the required zeros. For relationship, you need the values of a, b, and c. So we know that the general form of the polynomial is equals to ax squared plus bx plus c. So equating the given value with this particular expression, we get capital P is equals to 4, capital B is equals to 8, and capital C is equals to 0. Now, let me change the variables and consider variable x, but in the given question, the variable which is given to you is u. Here, constant is not given, so we can easily write plus 0, and the C value can attain this value 0. Sum of zeros. Sum of zeros is equals to 0 plus minus 2, which is 2 minus 2, and minus b upon a is equals to minus of 8 upon 4, which is again equals to minus 2. Similarly, product of zeros. Product of 0 is equals to multiplication of 0 with minus 2. This is 0. And C upon A is equals to 0.4, which is again equals to 0. From the two equations A and B, the relationship between zeros and coefficients is verified. Next, fifth value is t square minus 15. So, t square minus 15. Again, we do not have one term over here. We do not have the middle term over here. We cannot have anything common over here. This looks something like a square minus b square. 15 is not a complete square. So, you can write 15 as root of 15 whole square. Now it looks something like a square minus b square, where a is equals to t and b is equals to root 15. We know that this expression has an expansion a plus b and a minus b, thereby splitting the square terms into linear expressions. So this value can further be written as t plus root 15 and t minus root 15. Equating each expression with 0, t is equals to minus root 15 and t is equals to plus root 15. These are the required roots. You should write statements after every step. Now, for the second part, you have to verify the relationship between zeros and coefficients. So let's understand what are coefficients over here. We know in general form, the quadratic polynomial is given by ax square plus bx plus c. Here the middle term bx is not mentioned. So you can easily write this as 0x. Comparing these two, you get a is equals to 1, b is equals to 0, and c is equals to minus 15. Sum of zeros. Sum of zeros is addition of minus root 15 with root 15. Two values of the opposite signs are added with each other, leads to cancellation, thereby 0. Minus b upon a is minus, the value of b is 0 upon a is 1, which is again 0. For the second value, we should have product of zeros. So, product of zeros is equals to root 15 into minus root 15. Plus 1 into minus 1 plus minus will lead you to minus, and multiplication of these two quantities lead you to 15. C upon A is equals to, the value of C is minus 15 and A is 1. Again, minus 15. From these two values, we have verified the relationship between zeros and coefficients. Next. The last expression is 3x squared minus x minus 4. X squared minus x minus 4. Sixth value. Here, using middle term splitting method, you get 3x squared minus 4x plus 3x minus 4. Taking common amongst the terms, from first two terms, x is common, 3x minus 4. From the next two terms, 1 is common, 3x minus 4. This term and this term, you have 3x minus 4 common, and you're left with x plus 1. Equating this with 0, x is equals to minus 1 and x is equals to 4 upon 3. These two values are the zeros, required zeros. We know that the general form of quadratic polynomial is given by ax squared plus bx plus c. Equating this with the given expression, we get a is equals to 3, b is equals to minus 1, and c is equals to minus 4. Now, formulating a relation, sum of zeros is equals to 4 upon 3 minus 1, which is equals to 4 minus 3 upon 3, which is 1 by 3. Minus b upon a is equals to minus 1 upon 3, which is 1 by 3, substituting these values. Next, product of zeros. Products of zeros is equals to 4 upon 3 into minus 1, which is minus 4 upon 3. C upon A is equals to minus 4 upon 3. Both the values are equal, therefore product of zeros is equals to C upon A, and sum of zeros is equals to minus B upon A, which you can write here and then hence verified. The relationship is verified. Next. This was the end of the first question where we solved every possibility. Let me know if you have not understood anything. I can re-explain it to you in the next class or so. Find the quadratic polynomial each with the given numbers as a sum and the product of its zeros respectively. So in this particular question, certain values are given. What are these values? You have to formulate a quadratic polynomial each with the given numbers as the sum of product of its sum and product of its zeros. So the first value is the sum. 1 by 4 over here is the sum of zeros, and the second value 1 is the product of the zeros of the quadratic polynomial, of any random quadratic polynomial. You have to find the values of those quadratic polynomials. So let's start. Let ax squared plus bx plus c be the required quadratic polynomial. given that sum of zeros is equals to 1 by 4. Now we know that in a quadratic polynomial, sum of zeros is equals to minus coefficient of x upon coefficient of x square, which is minus b upon p. So equating these two, we can get minus b upon a is equals to 1 by 4. Let's say b is equals to 4a. Now, we also are given the value of product of zeros. So, product of zeros is equals to 1. Product of zeros means multiplication. Also, we know that product of zeros is equals to constant term upon coefficient of x square. So this is c upon a. So it's given that c upon a is equals to 1 and b is equals to 4a. Therefore, c is equals to a. If a is equals to 1, then b will be equal to 4 and c will be equal to 1. With this, we can formulate one quadratic polynomial. Ax square means x square plus 4x plus 1. But there can be n such quadratic polynomials. So let this be multiplied by k. Because instead of considering a as 1, we can have any value of k. If a is equals to small k, then b is equals to 4k and c is equals to k. Therefore, the required quadratic polynomial is equals to k into x square kx square plus 4k plus k. 4k into x or 4xk. Taking k common, you can have x square, k common, x square plus 4x plus 1. The same value. So either you can consider any value of a and then substitute, multiply it with k, or you can directly get the value, take the value of a as k. Now this would be a generalized form. This is a general form of based on the required values of sum and product of zeros. You can take any value of k as your final answer. So k can have any value. Say k is equals to 2. So your given expression becomes 2x square plus 8x plus 2. Next values. Next values are root 2 and 1 by 3. So for root 2 and 1 by 3, sum of zeros equals to minus b upon a. Sum of zeros given is root 2, which is equals to minus b upon a. Therefore, a is equals to minus root 2 into a. One second. Here, I should have placed minus 4. Minus b upon a is equals to 1 by 4. So, b is equals to minus 1 by 4. Therefore, b is equals to minus 1 by 4. b is equals to minus 4. Over here, the second terms will have minus sign. -4, -4. The rest is the same. Here, product of zeros is also given. Minus c upon a. Product of zeros given is 1.3 is equals to minus c upon a. Therefore, c is equals to product of zeros plus c upon a. Formula. C is equals to a upon 3. Now you have a fraction over here, so let us assume that a is equals to 3. A is equals to 3 will give you b is equals to minus 3 root 2. C is equals to 3 upon 3, which is equals to 1. Therefore, what do you have here? Your given quadratic polynomial is ax square plus bx plus c. This is your required quadratic polynomial. Where a value is 3, x square minus 3 root 2x plus 1. This is your required expression. Now, this much answer is sufficient. If you write this is your required quadratic polynomial, it's sufficient. In a general form, based on the given values, you can multiply this by k. Either of the two answers are correct. Next expression, next values. Next values are 0 and root 5. So for 0 and root 5, you have sum of zeros is equals to minus b upon a. So 0 is equals to minus b upon a. B is equals to 0. For product of zeros is equals to c upon a. Root 5 is equals to c upon a. C is equals to root 5 into a. For a is equals to 1, the value of b will still remain 0, but value of c will be equal to root 5. So your quadratic polynomial becomes ax square plus bx plus c is equivalent to x square. B's value is 0, so you need not write the second term. And the last value is root 5 plus root 5. Next values are 1 and 1. For 1 and 1, your sum of zeros is equals to minus b upon a. 1 is equals to minus b upon a. B is equals to minus a. And product of zeros is equals to c upon a. 1 is equals to c upon a. Therefore, c is also equals to a. So whatever value of a you place, for a is equals to 1, b will be the negative of it, minus 1, and c will be the same as a, which is equals to 1. Ax square plus bx plus c, the required expression will therefore become x square plus, minus, b's value is minus, so minus x plus 1. Next values are 1 by 4 and 1 by 4. Yeah, 1 by 4 and 1 by 4. So Sum of zeros is equals to minus b upon a that implies 1 by 4 is equals to minus b upon a. B is equals to minus a by 4. Product of zeros is equals to c upon a. 1 by 4 is equals to c upon a. C is equals to a upon 4. For a is equals to 4, b is equals to minus 1, c is equals to 1. And the required quadratic polynomial is 4x square minus of minus 1, which is plus x, ax square is 4x square, b's value is minus 1, so minus x plus 1. Next, 4, 1. Now, sum of zeros equals to minus b upon a. 4 is equals to minus b upon a. B is equals to minus 4a. Product of zeros is equals to c upon a. Product given is 1 is equals to c upon a. C is equals to a. For a is equals to 1, b is equals to minus 4, and c is equals to 1. Therefore, the required polynomial is x square minus 4x plus 1. In your second exercise, 2.2 of polynomial, there are only 2 questions. And we did both the questions with all its sub-questions, sub-parts. Hope you've understood it. Ask me any doubts in the comments below. We'll continue with this. We'll cover next exercise in the next class. Thank you.